Assalamualaikum, students and friends. In this episode, we take a second look at revised excerpts of two past uploads on tensile stress, specifically focusing on computing the breaking stress of a given metal alloy and the maximum acceleration of an elevator lifted by a cable with a given elastic limit. So just hang on, watch and learn. Questions are: number 1, in a material testing laboratory, a metal wire made from a new alloy is found to break when a tensile force of 90.8 newtons is applied perpendicular to each end. If the diameter of the wire is 1.84 millimeters, what is the breaking stress of the alloy? Question number 2, a steel cable with cross-sectional area 3.00 centimeters squared has an elastic limit of 2.40 raised to the 8 power Pascal. Find the maximum upward acceleration that can be given a 1,200 kilogram elevator supported by the cable if the stress is not to exceed 1/3 of the elastic limit. In question number 1, we're given the amount of the tensile force exerted on both ends of the wire. And we denote this tensile force with capital F. And to emphasize that this force is perpendicular to the cross-sectional area, we put here the subscript of a perpendicular symbol. And this force is equal to 90.8 newtons. Likewise, we are given the diameter of the wire, D equals 1.84 millimeters. Thus, the radius is equal to 9.20 raised to the negative 4 meters. And our target variable is the breaking stress of the metal wire, denoted here by capital F over capital A. Of course, capital A is the symbol for the cross-sectional area. So substituting our quantities into this formula for breaking stress, we get 90.8 newtons divided by 3.14, that's the value of pi, and multiplied by the square of the radius, 9.20 raised to the negative 4 meter. So when we do our math, we arrive at the value of the breaking stress of the metal wire equal to 3.42 raised to the 7th power Newton per meter squared or Pascal in 3 significant figures. In question number 2, we are given the cross-sectional area of the steel cable of the elevator equal to 3.00 centimeter squared. Also, the steel cable has an elastic stress limit F over A equal to 2.40 raised to the 8th power Pascal. And the elevator, whose mass is 1,200 kilograms, is moving upward. The target variable in question number 2 is the maximum upward acceleration, A sub max. Before we compute for this acceleration, we first determine the amount of tensile force exerted on the cable, which is just the product of the amount of stress and the cross-sectional area of the cable. And in this problem, we also consider this tensile stress as the tension force exerted on the elevator directed upward. And since the required amount of stress, okay, should not exceed one-third of what we call the stress elastic limit, 2.40 raised to the 8 power Pascal, we have to multiply this by one-third, or one-third of the elastic limit, then also multiply by the cross-sectional area, 3.00 times 10 to the negative 4 meters squared. So when we do our math, we get the amount of tension force, capital T, equal to 2.40 raised to the 4th power Newton in three significant figures. To finally compute the required upward maximum acceleration of the elevator, we apply here the law of acceleration. Acceleration A equals F net divided by the mass m. That is, A equals the difference between the tension force, which is directed upward, and the gravitational force, or the weight of the elevator directed downward, and then divided by the mass of the elevator. So when we plug in the given quantities into this formula, okay, we have acceleration equal to 2.40 raised to the 4th power Newton minus 1,200 kilogram multiplied by 9.8 meters per second squared, and then all over 1,200 kilogram. So when we do our math, we finally arrive at the value of the maximum acceleration of the elevator equal to 10 meter per second squared in two significant figures. So that ends our lesson. Mabuhay till the next episode. MashaAllah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel. Alhamdulillah.